Assalamualaikum and hi everyone. We meet again in my third video for electrochemistry. And in this video, I will explain to you how to predict the spontaneity of the redox reaction, the Nernst equation, and also factors affecting the redox potential. Alright, so to predict the spontaneity of the redox reaction, we have to look into the E cell value and delta G value. If the E cell is greater than 0, or the delta G or Gibbs free energy is less than 0, it will be the spontaneous reaction. And if E cell is less than 0 or delta G is greater than 0, it is non-spontaneous reaction. So usually in the examination, they will given to you the overall cell reactions. Some example of the question in the examination is that they will given to you overall cell reaction, and then from the overall cell reaction, you need to predict which half reaction is anode, which half reaction is the cathode, and then from there you need to calculate the E cell. And from the value of E cell, you need to identify the spontaneity of the reaction. So if your E cell is greater than 0, it is spontaneous, and if E cell less than 0, it is non-spontaneous reaction. Okay, so the relationship between the E cell and free energy can be found by using this equation, which is delta G equal to negative NF E cell, where N is the number of moles of electrons transferred, F is the Faraday constant, and 1 Faraday is equal to 96,500 coulomb per mole. So what Faraday we will learn in detail in my next video. Okay. So next we proceed to the factors affecting the E cell. Okay, there are 4 factors that will affect the E cell. The first one is the positions of ions in the standard reduction potential. So as you remember in the standard reduction potential table, the top, the one that have the more positive reduction potential will be cathode, and the one that have more negative reduction potential will be the anode. And if the half cell reaction is located farther away between each other in the standard reduction potential table, meaning that the greater the cell potential. Right. The next factors is the concentrations of ions in the electrolytes. Okay, so the concentrations of ions may due to the pH and also from the complex ion. So the concentrations of ion might increase or decrease the cell potential. Okay, it depends. And the next factors is the temperature of the reaction, because temperature really affect the Gibbs free energy, so it will in turn also affect the cell potential. And the last factor is the pressure of the gas when the reaction involves gases. So all these factors will change the E cell value, and due to that we need to find a new E cell. So this so we come up with a new equation to calculate a new E cell, which we call as Nernst equation. So Nernst equation, okay, is the general equation that relates the Gibbs free energy and cell potential in electrochemistry, and so it can be used to find the cell potential at any moment during a reaction or at condition other than standard condition. So Nernst equation is actually derived from the Gibbs free energy. Okay, to derive from this equation, but you can read more in the book to know how they derive the Nernst equation. But the most important thing for you to know is the Nernst equation. Okay, what is the Nernst equation? You need to memorize this one. So the formula for this equation is E cell equal to E naught cell minus 0.0592 over n log Q. Alright, so Q here referring to concentrations of product over concentrations of reactant, and the product and the reactants will be determined from the overall equation and cell notation. And n here is the number of electrons transferred in the cell reaction. Okay, so this Nernst equation you need to memorize. Okay, now let's go straight to the question so that we know how to calculate the E cell using the Nernst equation. Okay, so let's say reading into this question, calculate the cell potential of an electrochemical cell made of a chromium electrode in a 0.01 molarity chromium nitrate solution and a stannum electrode in a 1 molarity stannum sulfate solution. So given to you the cell diagram here, okay, or cell notation. Okay, right? So this is how you need to do it. Right. First, we need to identify the standard reduction potential for each of the half cell reaction. So this standard reduction potential is given to you in the question. Okay. So the standard reduction potential for chromium is negative 0.74 volt, and for stannum is negative 0.14 volt. So the next step, you need to determine which one is anode, which one is cathode. Okay, the more positive E naught reduction will be the cathode. So stannum, which one is more positive, stannum or chromium? Okay, stannum, right? Stannum will be the cathode and chromium will be the anode. So next step, you write the half cell reaction for the anode. So chromium 3 plus 3 ion, you got chromium solid. So E naught is negative 0.74. Okay. Because and for cathode, okay. For cathode, stannum 2 plus 2 electron, got stannum, so the E naught is negative 0.14. So this value we get from the question, okay. Because chromium, okay, undergo oxidation at the anode, so we have to put the electron, reverse the equation, okay, meaning that we have to put electron on the product side, because anode meaning that oxidation release electron, right? So the equation for the oxidation half cell reaction will be chromium solid, got chromium ion plus 3 electron. So when you reverse the half cell equation for the anode, the E naught value also need to be reversed from negative 0.74 to positive 0.74. And for cathode, no need to do anything because cathode undergo reduction and the value you get from the question is for reduction already. Okay, next step, to get the overall cell reaction, we need to make the number of electrons similar. Okay, for anode we have 3 electrons, but for cathode we have 2 electrons. So to make the number of electrons the same, we need to multiply the half cell reaction at the anode with 2, okay, and half cell reaction at the cathode we multiply by 3. Okay, so once you multiply the half cell reaction, you get the similar number of electrons. Okay, but you need to remember once you multiply the equation only the number of electron, only the equation affected. Okay, the E naught cell remain the same. Okay, no need to multiply 2 with 0.74 and 3 multiply 3 with 0.14. It is wrong. Okay. Okay, once the electron is the same, okay, you can combine these two half reactions to get the overall reaction. Okay, and then next step, we calculate the E naught cell. So E naught cell, we have two formulas, so you can prepare which one you can use. So for E naught cell, E naught cathode minus E naught anode. So cathode is titanium, so negative 0.14, minus anode chromium, so guna terus negative 0.74, you got 0.604. Or you can use the second formula, E naught cell equal to E naught oxidation plus E naught red. So E naught oxidation, you need to change the sign from negative 0.74 to positive 0.74. So positive 0.74 plus E naught reduction, negative 0.14, you will also get 0.604. Okay, once you get the overall cell reaction and the value for E naught cell, then only you can use the Nernst equation. So Nernst equation, the formula is E cell equal to E naught cell minus 0.0592 over N log product over reactants. So E naught cell is 0.60 minus 0.0592 over N. N is the number of electrons transferred, which is 6. Okay, 6. Log concentrations of the product. So you have to look at the product side. Okay, so solid doesn't have any concentration. Okay, only ion. Okay, ion have concentration. So concentrations of ion, chromium ion is given to me in the question. Okay, which is concentrations of chromium nitrate solution is 0.01 molarity. So meaning that concentrations of chromium ion is 0.01. Okay, and then for the product, and then because the chromium ion have 2 here, the stoichiometry is 2, so you need to put 2 here. Okay. And then concentrations of stanium ion, stanium 2 plus ion is 1.0. So because stanium ion here, which is located in the reactant side, have 3, stoichiometry, the coefficient is 3, so you need to put 3 here. Okay. So once you have all the values, substitute all the value and then calculate it, you will get 0.644. Okay. Okay, so next we proceed to another example. Okay, so in a test of consisting of zinc 2 plus half cell in hydrogen H plus half cell under the following condition, calculate E cell at 298 Kelvin. So for this one, just the same, you need to write the overall cell reaction and then you need to calculate the E naught cell. So substitute in the formula. So E naught cell is 0.76. Okay, minus 0.0592 over N. N is the number of electrons transferred, which is 2. Log Q. Q is the product. So product here, okay, you will see here. So we have hydrogen gas and zinc 2 plus ion. So hydrogen gas have a pressure, okay, indicated here, which is 0.3 atm. So you need to substitute the pressure for the hydrogen, which is 0.3, and concentrations of zinc 2 plus 0.01, and also concentration of H plus ion, which is 2.5 to the power of 2, because the coefficient for H plus ion is 2 here. So substitute into the Nernst equation, you get the E cell is 0.864. Yeah? Okay, so that's all.